Alrighty, looks like, I hope we're live. We've got a few folks here. The delay for me for streaming is a little bit weird, so we'll have to work on this. But anyway, yeah. Wait, we lost folks. We'll wait till 1 o'clock before we really get started. Looks like I'm losing viewers by sitting here. Awesome. Sweet. Hey, Billy. We'll wait till 1 o'clock to really get going. In fact, we'll probably wait till a few minutes after. Billy, can you tell me if you can hear me okay? I need to check my audio settings here. There's a little static, and I am quiet. Well, let's hope that we can get that fixed. Let me see what I can do about the volume. I may switch to headphones here, which is unfortunate. Oh, I bet I know what I can do. Let me try this. So we've got many audio interfaces hooked up right now. Many things with microphones hooked up. And OBS and REW sometimes fight each other, so we'll see how we can do what we can do here. Don't want to use any of those. All right, I may just lean forward when I'm talking. This may get a little awkward. Actually, let me try my headphones. I'll be right back. I know where they are. All right, let me hop back because I've got so many windows open. There is not a fan. Well, there's actually a fan in the background, but it's a refrigeration unit. I can't show it off. Is this any better for the sound? Did it automatically pick these up, the headphones? Brian, Billy, did the headphones help? Are you picking those up, or did that make it worse? You know what I'm going to try? I'm going to try this one. Can you guys hear me now? Is that any better? As I said, I have a lot of things with microphones, so I'm trying to figure out which is the best here. Okay, all right. Well, let me know. We're going to wait till at least 1 o'clock before we even remotely get started. Probably give folks a few minutes. I sound like in the can. Well, I probably deserve to be in the can. Or in trouble in the doghouse or something. I'm not sure. Yeah, I'm not sure which microphone this is. Let me see here. Let me go back to my input. We're going to do the classic thing that you should not be doing, which is the check, check, bang on the microphone. Oh, that's not. Which microphone is this? Oh, it's that one way over there. That's not the one I want. All right. I think this might be the best we can do here. Not sure these headphones are doing all that much, but hopefully we can make this workable. I apologize for that. As I said, I have 1, 2, 3, 4 things that can capture audio, 2 things that can capture video, 3 things that can play back, all going on here. So yeah, this is yeah. All right, well, we'll deal with this. I think this might be the best. I'm not sure it's actually coming through these. Don't think I even need these headphones, so we'll do this. Yeah, too many mics and not one that works quite what I want it to for what we're doing here. So, oh well, I'll live. There's a lot of windows for me to keep track of right now. Sorry, guys. I'm relatively new to this. All right, what time is it? All right, we'll give folks some time to log in. I actually logged on before 1 o'clock. Hey, Daniel. We've got a Daniel. Daniel, what time is it for you? 8 p.m., 9 p.m.? I'm not keeping you up too late? Brian, if they're doing the vacuuming and you're not, I'd call that a win. Just saying. Just saying. I think that's okay. I'm glad I'm not keeping you up too late. So I don't know how far we're going to get today. I, of course, in my mind had this idea that we were going to be able to do like all the near field merges in the world and all sorts of fun stuff, but I'm not sure how much of that we're going to get through. So we'll just get through as much as we can before my wife and kids demand my presence for stuff. I also want to keep working on these speakers. Hey, Byron. Welcome. Glad you made it. I'm actually going to go post in those groups that I have gone live. I think I gave a warning. Forget it. If they're not going to show up. Scott live stream greater than physics assignment. I really don't know how to take that. Yay. I would hope so. Shame on you for abandoning the homework. I'm really not sure where I fall on the spectrum. It's a multi-emotion event, really. There's we've give folks one more minute. Come in. We have a few viewers. I would suspect that we're going to get more as we go. Unfortunately, they're going to miss the stuff at the beginning. Luckily, you can go back. I'll leave this recorded live, or I'll leave the recording on for everyone. So. All I know is that during college, it did not take much of an audio thing to get me distracted, so I know how that goes. There were many hours spent simulating speakers that I had no hope of building. All right, it's 1:05, so we're going to go ahead and get started. Thank you, everyone, for joining me on your Sunday, whatever it is. I guess I'm trying to think what time it would be in Australia. It's too much math. So thank you. I hope this is useful. I hope this is entertaining as something like this can be. I'm going to start off literally from scratch with REW because I think there's a lot of mistakes that folks make at the beginning in terms of setup. We will not get through all of the potential ways to do things today because it's such a powerful program that there is just no way to do that. So what I've done is I have installed REW, but I deleted my preferences, which as folks that are familiar with the program, once you kind of get it the way you like it, deleting your preferences is not something you'd like to do. 7 p.m. Okay, in South Africa. All right. Okay. Well, welcome from South Africa. That's awesome. I love the internet. It's so cool. So I have deleted my preferences and I'm going to start from scratch. I currently have a speaker. You can see, in fact, let me sort of enlarge this video. Nope, that's not how it's done. You can see my exceedingly messy workshop here. Got some amplifiers going on in the background there, some stock, some wood over there. And the speaker that I'm going to be performing these measurements on today is a two-way that I'm working on. This is sort of the public unveiling. So what's better than trying to do something new with a lot of technology is surprise yourself with how a speaker is going to measure by measuring it the first time in public. It's going to be a two-way speaker, hopefully with a Vital Pro HF100 to keep the cost low-ish. And an STH100 horn. The woofer is not going to be particularly inexpensive, but it's a nice one. It's the Vital Pro 8RS250. So this is a compact speaker with high output potential. The tweeter is not in its final form factor as it currently sits. I was not able to get this done for today. I do not normally, deploy speakers for their final purpose with masking tape holding the speaker onto the cabinet. But yeah, that is where we are today. So yeah, I'm going to start REW, and we're going to go from there. And actually, let me. Yep. Let me see if this is popping up a window for me. No, it's always going to go back to the main one. Yeah. All right. So when you first start REW, if you have, and because of the way that the tech demo, what could go wrong? Everything, Byron. Everything. It will all go wrong. I guarantee it. So I have a U-mic, mini DSP U-mic attached. This is actually a relatively new one for me. I didn't get this one too long ago, and I never opened it. And I opened the box and brought it out for this demo. So when you start REW, and for some reason when it's REW's got this, I can't move it to the screen. You're going to have this pop up that says, "Do you have a calibration file?" I'm going to say yes. And then in the newest version, it brings up a input for your calibration file. Okay, if you're not using a U-mic, this won't happen. It pops up other warnings about being uncalibrated, etc., 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 and you kind of click OK. But I highly suggest, for the cost, that the U-mic is a great way to go. The Dayton mic works pretty well for this as well, but I've never used it. I don't own one. I've actually used it. I don't own one to demo with here. So I'm going to browse and get my calibration file. And now I'm going to hopefully, now I'm going to be able to bring over REW. Okay. So this is the basic screen, first install kind of a deal. And there's a couple of things that we're going to want to do first. The first thing you're going to want to do is pick your inputs. Okay. So whoops, not measure. That is not what we're going to want to do first. We are going to go to Preferences. And of course, they keep popping up on, there we go. Okay. So because of what I'm doing today, as I said, I have a bunch of things hooked up. I've actually got a Scarlett 2i2 that I'm using as the output. For the purpose of today, I'm going to be putting the output as the default output, left plus right. So it's going to output the same signal on left plus right. We're not going to deal with timing and loopback today. That'll have to be another demo. I've got the input device is the microphone, the U-mic, and if you these, every once in a while, these will get changed on. You have to bring these back. Yeah, so this is picking your output and your input. If I picked a default device, it might pick the microphone internal to the laptop. If I picked primary sound capture driver, I'm not sure what that's referring to right now. That might be referring to the web camera that's on the speakers right now. No, there's the Logitech webcam, so I'm not sure which one of those are. There's a whole bunch of devices, but for us right now, we want the U-mic, right? So I'm not going to change anything. So first thing I'm going to do is make a quick sweep, because this is something that a lot of folks will do, is they pick their inputs and they're like, all right, I'm ready to go. We're going to see what this looks like, because I have a feeling it's going to be sort of a mess. I'm actually hooked up to that tweeter right now, so I'm going to change my start frequency to the sweep, and I don't remember how loud I've got it, so I'm going to change my output down quite a bit, and we're going to give it a whirl here. Okay. All right. So this is what you would see if you took your very first measurement in REW for a tweeter. Okay. And I've seen a lot of folks look at this and they don't understand what's going on. And then they start sort of messing around to make it look reasonable. And there's quite a few mistakes that folks make here. So I'm just going to play a little bit with scale. So the first thing they do is they add smoothing. And a lot of times what they'll do is they'll change the axis limits to make things look even flatter, especially if they're measuring like speakers in room. And I've seen some rather hilarious versions of this. Okay, so like this is quieter than atoms moving right now to high volume, and of course now the speaker looks fairly flat up here, but that's not realistic, right? So I'm going to, for the purposes of today, set this for 110 and 60. So I have a 50 dB range, and I'm going to take off my smoothing. Okay. Now, the default for REW is a quite wide window. Okay. It's a gated measurement system. We can zoom in on a period of time that we want to look at that is quite small. And as a result, narrows down and eliminates the room reflections and all sorts of other things, which is what we're seeing here. We're seeing all of the echoes. But I don't like the default impulse display. So I'm going to go over to the impulse window here. And this is what you see when the program first starts up. So what are we looking at here? We're looking at energy versus time. Okay. And so in the units of dB, and this is weird, if you're doing room acoustics measurements, this is actually a very useful display, but when you're trying to look at a speaker, this is not a useful display. I have never found this particularly useful. So I change it to %. And now you've got a picture of the impulse, still very long, right? We've looked, we've got a second of time displayed here, which for measuring a speaker is forever. Okay. That is a very, 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 very long time. What you can do, though, is use the graph here, change your graph axis limits to go to a reasonable time. And if you're measuring speakers in a room like I am, the time is very short. Sound is fast, right? 343 meters per second at room temperature and sea level. And so you end up having to really zoom in on it. Whoops, wrong way. And now I am looking at a very, very small section of time. Okay, I am looking at 20 milliseconds of time. So this is a very, very short section of time. And what you see is this is the primary impulse coming from the tweeter. And this is the first reflection, whether or not that's floor or ceiling. They might be lining up pretty close to it at the same time where they are, right? So we're going to want to set our window, the period of time that we're looking at, to be only that little bit, okay? And there's a couple of things that you have to watch. The first thing is you have to watch where your reference time is. And I may not get into a lot of this, of dealing with this reference time, what that is on this video. Turns out I've been using like beta 30 or something like that for a while, or maybe even 10. And some of the behavior around this has changed since when I was looking at this morning. So I may have to come back to this. I may have to look at this a bit more and then come back and talk about it on another video. So what I'm going to do is I'm going to click this IR Windows button up here. And this lets me set the windows, okay? So my left window right now is 312, so it's 0.3 seconds before the impulse ever started. That's a really long time. It doesn't need to be that. I'm going to set it to 1 for right now to bring the cursor in. And I'm going to set this one for 4 milliseconds. Okay? Now, close this, and guess what you see? You've got this window here, and you can click on these, and this is a cool feature that John added a while back, and I love it, because it allows you to see if your reflections are starting to creep in, okay? So I'm going to move this here, and now I'm going to take this right side, and this is that floor or ceiling reflection that I talked about, and I'm actually going to start letting some of that creep into the measurement. And look what we're seeing over here, okay? I'm going to apply Windows and go back. See how you see this ripple? That tells you you've got a room reflection added into the speaker. Most speakers don't have this much ripple just on their own, okay? So I'm going to go back to that impulse window and drag this back here, and now I've eliminated that, okay? Apply that. Now we go back to our SPL window. Now I've got the SPL for the tweeter, all right? This is a useful speaker measurement, okay? You can actually see what's going on here. Remember earlier when I had the limits set really wild? I'll do it again. Like quieter than the sun, or quieter than a molecule. We'll go louder than the sun, right? You see this all the time. That's not louder than the sun. That's just a car audio. But you see this all the time where now people are looking at this and say, oh, look how smooth my speaker is. Well, it's not. You've just plotted it so smooth, right? So back to useful settings, okay? But what we don't know is exactly what voltage we put into the speaker, okay? I have just set it up, I've set the volumes, and I've played the tone, I played it, and I have no idea if this is a 2.83 volt measurement. So what we're going to do is figure out how, or what I'm going to show you is how to measure that, right? So everybody with me so far? Do we have any questions? Can you hear me? Am I just talking to myself for 29 minutes, which would be awesome? It would be like a normal Sunday, really. This delay is killing me. You guys are seeing it probably a good 20 seconds or so after I do it. All right. So what I'm going to do is I don't want to be putting a 60 hertz tone into my tweeter at 2.83 volts. That would be bad. So I'm going to unplug the tweeter. All right, so I've unplugged the tweeter. Now, I'm going to use a feature of REW that John added a few revisions ago, and since he added it, I love it. This is fantastic. I've got a wire issue happening here. Hopefully we don't hear a crash or a bang or Scott crying because I dropped something expensive or unplugged the live stream. Hold on, I'll be right back. I gotta go get that wire. Okay, so I have a trusty voltmeter with an untrusty battery. It is going on me. I don't know if you can see this. Okay. What I'm going to do is I'm going to use the generator function of the REW. Okay, and I'm going to go to 60 hertz. Okay, use 60 or 50 hertz because even inexpensive DMMs will read that properly. If you're too high in frequency, they're not going to read it accurately. Okay, like aircraft power, internal AC aircraft power often is 400 hertz. They might be able to do that, but sometimes when you get into the 1,000, 2,000 hertz range, they don't read properly. And what I'm going to do, since I've got everything unplugged, I am going to do something relatively scary, and that's go to 0 dB full scale. I am going to put the full scale output of this thing, and I'm going to double check that I'm unplugged. Yeah, okay. All right. We are, no. I'm fooling myself. I'm not unplugged. Hold on. Double, quadruple, triple check. Okay. Now we're good. That could have been bad. 10 volts RMS into a tweeter at 60 hertz. Poof, tweeter gone. You know what? All right. I'm going to start off. We're going to do just a quadruple billion check. We're going to make sure that we're not putting anything out into the tweeter. We are not. Okay. So back to 60 hertz. Back to full scale. Yeah, we will not let the magic smoke out today. Hopefully. So now I'm at full scale, and the amplifier I'm using for this is a Mackie FR1400. So I've only got like 300 watts per channel here. So it could have done a lot. Now I don't have the gains turned up all that high on it, but it's high enough, right? When you do this measurement, you want to make sure your amplifier is not clipping. So you're going to want to use your volume control to make sure that there's no clipping, because that'll change the measurement on you. Okay. So I'm going to play this 60 hertz tone now that I know I don't have the tweeter connected, and I'm going to show everybody what I'm measuring. Okay. So I am measuring short-term memory loss, 10.3 volts. Okay. Now, here's the coolest feature that has been added to me anyway. I found this stupidly useful. Okay. So I'm measuring 2.83 volts at 60 hertz. Okay. Notice there is a full scale sine VRMS I'm going to type 10.3 volts here. Okay. I am now going to click on volts. And now it is displaying the output in volts. All right. And now I'm going to change this to 2.83. That is minus 11.22 decibels full scale. I didn't have to do that math anymore, which is what I used to have to do. And lo and behold, what is the DMM showing? 2.86, but close enough, right? For our purposes, that, I'm not sure if it's the meter or the gain or whatever, but that is close enough to a 2.83 volt measurement. So now I can start measuring and find my true 2.83 volt 1 meter sensitivity, because the calibration file for the U-mic has that. It should be reasonably good. I haven't checked this one against my Cross Spectrum Labs mic. It should, in terms of absolute SPL magnitude, and it should be reasonably good for frequency response. It's probably going to be a little bit wonky, at least historically they've been a little wonky above 15 kilohertz. But now I have the ability to basically, as long as I don't touch any of those volume controls that I had, right, I have the ability to specify voltage into the speaker driver, which is really cool, okay? So now I'm going to stop my 60 hertz test and hook everything back up. You're hooked up. You're hooked up. Oh no, you don't want to be hooked up. Sorry for everybody for my chin. Okay. So now I am going to take another measurement, and I did not plan well and keep my. So now that I'm at 2. I am going to do this. I'm going to be nice to this tweeter and not do a 2.83 volt sweep at 20 hertz. So now I'm going to do a 2.83 volt sweep from 400 hertz to 20 kilohertz, and this is going to be loud. So I'm going to plug my ears after I press start. Okay, now look at what has happened. We have a much louder signal. I'm going to have to move this scale up. And we have gone back to our old wonky looking frequency response graph. Well, there's a way to make this easier and so that it does this for you every time. Remember those settings that we had for this one? IR windows, left window 0.33, right window 4.08. You can do that. You can set that up as a preferred analysis. What you do is you uncheck set window widths automatically. We'll just put 4 here. And we will put those in. And now I'm going to take another measurement, assuming I did it right. Let me see. Let me go make sure. You can also, if you want to, you can have it do a little bit of smoothing every time. I'm not a fan of smoothing. Like, I despise it 99% of the time. So, all right. I am going to take another measurement. Oh, here we go. And lo and behold, what happens? But the measurement comes up and it's gated just the way we want it, and we don't have to go type that in every time. So I don't want this one anymore. So we have now taken a 2.83 volt, 1 meter calibrated, because my microphone's at 1 meter, calibrated SPL measurement for this tweeter. We've eliminated the room reflections, and we have basically set our windows and all that right, and we've calibrated it to a fixed voltage. And my battery is running out, so I'm going to remember to shut that off. because I don't have any other 9-volt batteries. The kids have swiped them for their toys. So, any questions so far on what I have done? This delay is killing me. I just need to get over it. It's really hard because you guys are seeing it like 30 or 40 seconds after I've done it. And what I don't know is if I've like blown past something that you want me to go back to, right? So if you do, put it in the chat window. I will try and get back to it. I'm sorry if it takes a few clicks or we have to undo something or we have to redo something just to get there again. We now have a good frequency response measure. REW, because it's a swept sine measurement tool, does other measurements at the same time. One of them that's really, really handy is distortion. Okay, so I'm gonna click. The distortion screen. As it stands, the distortion is as it stands, the distortion measurement as its default display, I don't find it particularly useful. I did, my degree is in electrical engineering. I've done amplifiers design for so many years that I'm used to looking at it in terms of percent, not in dB under the fundamental. So what I usually do is change it, again, using the units here, is percent. It'll automatically, on the newest versions of REW, change it to relative to fundamental. At least that's what I read in the manual this morning. And then the catch is that it usually does puts the bottom and top so far that it's fairly useless. And because there's so many things, I sometimes find the harmonics useful to look at, but for the most part, I'd usually just look at second and third and THD. And so at 2.83 volts, second order harmonics dominate, and they really don't take off until you hit, I have to do a little investigate. This spike might be a little bit bothersome in a final speaker, so you might have to do a little investigation on that. But they really don't take off till about 1.8 kilohertz. So you could probably cross this over fairly low. Let's see, Brian, yes, I usually do almost all my measurements at 2.83 volts. And the reason is because I will, or higher, because I will very often go to this distortion screen to tell me if the driver is behaving at these levels. You have to be careful running, especially the tweeters. You don't want to be doing a 2.83 or a 4 or a 16 volt sweep with the tweeters at low frequencies. You want to start at like 400 hertz or even higher. You let the distortion and frankly how they sound tell you if you're pushing them too hard. I have had tweeters complain to me mightily, and I've actually blown them up once or twice on this, but I have found that to be extraordinarily useful for checking to see how well I think they're going to, and where I need to be crossing them over. So yes, I do run almost all of my sweeps at 2.83 volts. And for the horns that you can see over there that are 105, 108 decibel sensitive, my neighbors hate me, and my family hates me, and I'm okay with that. I can live with it for the purpose of science. It's all about the science. Anyway, Brian, let's see, when you run your sweeps, it's not loud at all. If I turn it up, it gives an error. Okay. Without knowing, I'm guessing the error is the clip detect error, and that could be caused from a couple of things. So yeah, message me over it my Facebook page. The link's there. 500% at what's this, Brian? 500% THD. This tweeter seems upset at that label at 8. It's not 500%. It's just 50%. Where are you seeing 500%? And frankly, that's probably dominated by the room noise, Brian. I'm not real sure that that's really real. You can see if I go back to dB full scale, you can see that at that point the tweeter level is starting to drop off. So as it's dropping off, the room noise is starting to come in and pick up. Okay, so that's what you're seeing there. What I'm looking for is where it starts to take off like this. Like it's good, drops, and then starts to pick up. This point right here, and as I said, this is somewhat concerning. This may be a little honky if I don't cross above that. Like I might want to try and do this at 2.2. I'd have to see if this, let's see. Yeah, it's in both these measurements. So yeah, I'd have to see exactly where what's causing that. That may also be because I've got that tweeter horn just sitting there. That may be a bell resonance picking up on that harmonic and accentuating it. So we have to look at that. Sorry, 50%. So that, and honestly, as I said, because that's room noise, to me, I don't know how it came across on the video. That actually sounded pretty clean the whole way through. Your ear, depending on which harmonics there are, is very happy to ignore 5-10% harmonic distortion. It depends on frequencies and which harmonics they are and things like that. But second order harmonic, it's just not going to sound that angry. Compression drivers are like dome tweeters sort of get angry slower. Compression drivers like this one, like it'd be okay, and then and it'd honk at you and it'd be really ugly. Okay, so now I've taken the measurement at for the tweeter. I'm going to go switch the wiring around and we're going to take the measurement for the woofer. Okay, and I'm not going to move the microphone. Not going to do that. I'm just going to go change the wiring around. Be right back. Okay. Don't trip and fall. Don't trip and fall. Okay. So now I have the woofer hooked up. I am still going to do this at 2.83 volts, but I'm going to go down to 20 hertz. And I'm going to take the measurement. Oh, something's wrong. Tech demo, live. Of course, we had the problem. What happened there? Do I have a bad cable? I'll be right back. Oh, I know what happened. Dang it. All right. Well, okay. Yes, we want that measurement removed. Okay, so now I have my woofer measured. I'm going to have some crossover work set out for me. Yeah, that's going to be neat. All right. So now I'm going to go to the all SPL measurement. Now I'm going to remove this one. Okay, so now I have both the woofer and the tweeter measured. But I have them measured at 1 meter. And what that means is that I am limited down because of room reflections and things like that, below 250 hertz. If I try and get data, I'm going to see room reflections added in, okay? So what that looks like for the woofer, and in fact, looks like the woofer's starting to creep in, is this. Okay, so as I move out, you see all that ripple start to kick in. Oh, it automatically applies that now. Cool. This, you know, if somebody looks at this, they're frankly, they're going to be horrified, and it's not a good measurement, and I've got all sorts of room stuff in there. But you start to see baffle step kicking in, although this seems to be a little bit low. So this may be a perfectly good example of why you can't trust an in-room measurement, because a lot of times those reflections and things like that start to add peaks and dips where your baffle step frequency is, right? And that is bad. You're basically lying to yourself if you believe that, right? So I'm going to go back and change this. We know what the reflection amplitude is. Okay. Now, I'm going to do one other thing here, and that is I am going to measure both the woofer and tweeter simultaneously in parallel. You need, when you do this with like 4-ohm speakers and stuff like that, you need a pretty healthy amp to do this. But this will come back later, and we won't be able to finish this because I'm already seeing them at 52 minutes. But you'll use this later when you put these responses, these individual responses, into like your crossover simulation software. You'll use this to check your relative offset between your tweeter and your woofer. And so that you have that right, okay? If you can't get that right, then your crossover modeling isn't going to be right either, okay? So let me do some more wiring. I had no idea how much wiring I was going to be doing on this thing. Now, this is where you have to be careful. I don't want to do this to my poor tweeter at 2.83 volts at 20 hertz, although I've done it, it'd probably be fine. I'm going to change this to 1 volt RMS, also to keep the volume levels reasonable. Okay, so now I'm going to go back to this screen, tweeter off, woofer off. There's a couple of things that we can do. One of the things that we can do is that if we look at our measurement here, 1 volt is minus 20.26 decibels. 2.83 volts is 11.2. So that's roughly 9 decibels, roughly, right? So what you can do is you can now take this measurement, and you've got some actions. Oh, he changed this. Oh, he changed this. You can add 9 dB to this. Now, it's back up to that level, and I didn't have to make myself deaf or worry about breaking a tweeter. So now I can go through and I can, looks like I might have added a bit too much to it. But the important thing for this is that, see how it's got some dips here? When you simulate, when you put this into, and again, this is sort of more advanced stuff, when you put this into your crossover simulation and you run the tweeter and woofer without a filter in your crossover simulation, if you're not seeing these dips in the right magnitude and place, then you don't have that acoustic offset right between the tweeter and the woofer, okay? And that means your crossover, when you simulate the crossover and you actually build it, is probably not going to sum quite right. Sometimes the errors are small, sometimes the errors are very, very large. And this has driven me crazy. I actually had a speaker where I didn't realize there were some digital delays getting in there, and so there's often some issues with this. That's part of a whole nother video that I've got to do, and so we'll hit that at a later date. Okay, now I'm going to do some near field stuff. Okay, so notice that I haven't moved the microphone. In the past, I have actually gotten to the point where I've put a stick on a stand, so that if I ever need to bring the microphone back to this location, I can. Okay, because sometimes you lose measurements and things like that, and you need to be able to get back to the exact location that you were before. I've actually known folks that will never move the microphone. They'll just have a second microphone that they do for the near field stuff, and they switch between the two of them. Okay. In this case, since it's just a demonstration video, I'm going to move the microphone, which means we've lost our reference place forever. Oh, there's one other thing I want to show. The impulse response. In fact, I'm going to do this one more time. This is a cool thing. Okay, good. I'm back to 1 volt. The impulse response. Okay. There's a cool trick you can do, and again, another video. I always run out of time. There's a cool trick you can do with a second speaker next to the microphone where you can check offsets. There's also the loopback method. There's all sorts of cool stuff that you can do here. But this impulse response, let's see what it looks like as a step response. Nah, it's not going to be helpful. Is basically showing that right now, it's looking like, to me anyway, that the tweeter is arriving slightly after the woofer is starting to arrive. So you know what I'm going to do? I'm going to go move it. We can do this. Okay, now I've moved it back a pretty good distance, and what we're going to see is the reflections creep in from the top of that speaker box, because there's no way it's going to miss it at this point. Oh yeah, look at all that hash up top. Aha! Okay, so here is the tweeter, and way in front of it now is the woofer. In fact, I'm not even capturing the woofer. Now I've got the woofer, okay? And now if I go back to this SPL screen, all this ripple that is up here, that's the reflection off the top of the cabinet, okay? So you can use that impulse response to sort of, I actually wrote a paper on DIYRM about time aligning PA systems. You can use it to, as I put it in that paper, park your DeLorean in kind of the right spot. It's not quite right. It's really hard to do that visually. It's not that the information's not there. It is. It's just that visually, a few degrees in phase is almost nothing that you see visually. And if you're making sort of wholesale visual changes to where that impulse is lining up, a lot of times you've gone way past where you need to be once you add the filters in, blah, 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 etc. But anyway, you can use this, as I said, when you put your crossover in the simulator to double check your relative offset. You can see how moving the tweeter changed. This dip disappeared, right? Like this dip just completely disappeared. Whether or not that disappeared because of reflections filling it in or time, I'm not 100% sure. But it looks to me like this dip moved down to here because of time, because I've shifted that tweeter back. So now I'm going to go do a near field measurement on the woofer. We'll take another 15 minutes or so, and then I will shut it down. So we're going to take a near field measurement on the woofer, near field measurement on the port. I'll show you adding those two together. And then I had planned on importing a baffle step and sort of merging everything, but we're just going to have to merge it, and there's going to be some error, and I'll point you to a paper that I wrote on making that merge correctly, so that you avoid sort of the error of baffle step disappearing from your near field measurements, because that is an error. All right. Oh no, I lost time reference. It's gone forever. All right. I am now near field on the woofer. 1 volt may be too loud, but we're going to find out. In fact, you know what? We're just going to go down to 0.5 volt because I don't want the woofer dust cap to smack into the microphone. And I've done that. And I've done that on some very expensive drivers. And it's not good for the microphone. And it's not good for the driver. Okay, now I have a near field measurement on the woofer. So, here's the deal. When you do that near field measurement on the woofer, the impulse response that you get, this gating that we did, that can go way far to the right, right? The room reflections are going to be so tiny in magnitude that they almost don't matter. So there is my been there, done that. Yeah. I think if you've done enough measurements, you've smacked the microphone with the woofer. I did it with the 18 HP 1030s, and I smacked it so hard that I moved the microphone back in the whoopsie. So luckily that's a really hard dust cap, and it was fine. But that could have been bad. So now, I am going to look at this near field measurement, okay? I'm going to turn off phase at this point because and I'm going to turn off my mic cal because that is just going to make it confusing for us. This minimum is the tuning frequency for this cabinet, and that is, if I remember correctly, right about where I wanted it. So good for me. Yay. I'll have to go back and look at my simulations, see if that's exactly where I wanted it or close to where I wanted it. So now I'm going to go measure a port. Okay, so you saw how much time I took to do that. I got the microphone lined up on the dust cap pretty easily. It's really important to be at the center of the port and right flush or even slightly inside that port to do the port SPL measurement. If you're off center-wise, the shape starts to change. It does weird things. Ooh, I have a pipe resonance. All right, so same thing. Move that window way over to the right, not that far. Oh, yeah. This is an unstuffed box, so I'm not real surprised that this is happening. But yeah, ooh, that's, ooh. This is what happens when you do a demo live. This box may not get a final build this way. Rats. We'll see. We'll see what stuffing it looks like. So now I have the near field port. Its peak is right around that 45 hertz range, which is good. That's where the minimum was. They should line up. If they shift too much, you've measured your port wrong usually. It is possible for them to shift ever so slightly, but most of the time that's a port measurement error. Okay, so now go back to the all SPL, and oh my gosh, look at all these plots that we have. So what I'm going to do, I'm going to start labeling some of these. Woofer near field, port near field. Yeah, Daniel, it's unstuffed. I finished this box, the construction, about 20 minutes before I started this, and I didn't feel like going out to the storage shed to get the stuffing, so I just put the woofer in it, and now I'm probably paying for that. I probably should have gone and done that. I mean, it'll improve it, but not sure. And since this is front firing, that may be more than audible. Oh yeah, it'll help, but that's when it's bigger than the port. I don't like that. Anyway, plus if we look, where is that? Near field, how do you do drivers? That's a great question. You get right next to the phase plug. You get as center as you possibly can. You get right next to the phase plug on the woofer. I have actually measured there and the tip of the phase plug to see if there is a massive difference. And then I have verified by taking them out ground plane and found that a lot of times that sort of that joint where that joint is where the phase plug is sort of hitting the cone, and that's the best spot, because what happens is if you're up here at the tip of the phase plug, you're awfully far away from a moving thing and you're not truly near field anymore. So that's been my experience. Your mileage may vary, but the way that you can check that is to do a true ground plane measurement out in a big wide open space. Put the speaker on the ground, put the microphone 2 meters away, and then you can double check because now you can run quite long gating if you do it that way. But yeah, that 500 hertz, yeah, it looks like that may be starting to creep in there. So, but again, this is an unstuffed box. So shame on me for being lazy and not going out to the, shame on me for being lazy and not going out to the storage shed. I knew I should have done that. I knew it. Anyway, all right. So all SPL, woofer near field. Yeah, see, near field, we've got some stuff going on here. So now a lot of folks scale this by using the port areas and things like that. I don't. I totally cheat. Port near field. I want to copy that response so I have a good one now that I'm about to mess with this one. Down, down, down. Yeah, that's looking weird. Something. Let's see if this may be where the demo truly comes off the rails, because that is not looking. That is not. An impedance would help me here too, but let's see. Yeah, that's not right. Something is not right. Huh? What did I do wrong? Yeah, because that is not enough output. We're gonna pretend that never happened. Oops. That is no good anymore. This is not reporting your field. Yeah. Let me try one more thing. Yeah, that's confusing me. I'm going to have to come back to that one. All right, so now that we're going to end this on a low note where I have totally screwed something up with that port measurement, because that is not scaling right for some reason. And I know I have 2 of them, but even if you add 3 dB, that's not right. So that is some basic measurements and a screw up, because it happens to everybody, on using REW for these kinds of things. This is going to bother me. Give me a second here, folks. What did I do wrong? Unless... yeah, because that port, it should be... what did I do wrong? The yeah, because I'm having to take, even if I add 3 dB to that, well, we'll try it. Let's see. Measurement actions, port measurement 2, response copy. Trace arithmetic. Is it 6 dB? Okay, well, that may be better, but it's still not. Now you guys are getting a lesson in all the trace arithmetic that we can do. And you can actually do some things that don't mean anything in real life, but let's see. Yeah, this is not an extended base shelf. There's something weird going on. I'll have to figure that out at a later date. Any other questions? I will figure that out, by the way, and I will post a something on DIYRM as to what I did wrong there, because that should have worked. But I'll have to figure that out later. Any other questions? Very interesting to see how the unstuck box and the port impacts wolf results. Oh yeah. That can. In fact, we didn't do an impedance measurement, But I wouldn't doubt that we've got all sorts of wiggles in an impedance measurement that would be helped. This box has dimensions internally. I was sort of working with restrictions on what this box needed to be external dimension wise, and so internally this box has a lot of dimensions that are similar. So there's going to be some standing waves that could be stacking up here too. And they could also be leaking out. So I'm not sure which one we're seeing here. That's why I cheat and use transfer function. Yes, I have totally cheated before where I use the simulation and I just merge that in, Brian. Yes, I have totally cheated. I was also desperately hoping today to be able to measure outside. And you can see me sweating. But it is sunny and 90 something degrees today, and hot and humid and mosquito-y and windy and disgusting. It's like 85 degrees in this garage. And so ground plane measurements outside were not going to be doable today. But that's the other way that I have totally cheated. If I can't get this to work right, like I've had some slot ports and things like that where there's no good spot. Like I can't seem to get a good spot near field on the port to measure it. So, and it had some port resonances and it was such a large speaker that like I couldn't get it high enough off the ground to get a long enough gating to get all the diffraction things to kind of creep in and everything. So finally I just gave up and I took it out to a parking lot of a mall that had been abandoned. And ran everything off of an inverter from my truck and measured ground plane at 5 meters. And that was the only way that I could get a reasonable resolution below 600 hertz. And I was able to get like 20 hertz resolution with the windowing that I still had to apply because of the buildings. And you could see all kinds of stuff creep in there that you would never have seen if you had measured close to the thing. What else? Is there any other questions? Is there something that you wanted me to show you? Anybody that's still hanging in here, any of the 10 current viewers, that I haven't gone through for a basic. I mean, this was fairly fast, right? This was only an hour. And I went fairly fast over some stuff. Let's see if I missed something in the chats earlier. No, it doesn't look like I missed anything in the chat. All right, well, if that does it, I will end the stream. Everybody enjoy your Sunday. Have fun. I am going to dig into why this port measurement wasn't working, because live demo. Of course, live demo. Anyway, and then as I said, I'll write it up and put it on DIYRM once I figure it out. Basically, I'm going to go take a bunch of impedance measurements, and then if that still doesn't work, later on this evening, I'll go put this thing outside, move all the cars, and put this thing outside if the wind dies down on me. Because right now it's just so ugly out there, and we're at pecan season here in Austin. So basically, while we were measuring, these large pecans would occasionally drop out of the trees. So, all right, everybody, have a good one. Thank you so much. Talk to everybody later.